So dear students, in this video we are going to study limitations of Ohm's law, limitations of Ohm's law. So let us preview what is Ohm's law actually is. So Ohm's law was actually when you have a circuit, connected with a battery of potential difference V, then there will be a flow of current in the circuit I, and if R is the resistance of the circuit, then these three quantities will be related with a relation which is V is equals to Ri. So this is our Ohm's law, which actually uh, tells us that potential difference is always proportional to current flowing in the circuit. So this is our Ohm's law. That means, according to Ohm's law, when you plot a graph between potential difference and current in the circuit, then we should get a straight line graph. So this was our Ohm's law. But there are few limitations to Ohm's law, or few drawbacks of the Ohm's law. So those limitations are as follows. So those limitations are, first limitation is this: at high temperature, at high temperature, this V, which is potential difference, ceases, which stops to be proportional to current. So at high temperature, this potential difference V ceases to be proportional to I. That means when you plot a graph between V and I, actually it should be, according to Ohm's law, it should be a straight line graph. But at high temperature, this graph ceases to be proportional. That means it do not becomes your perfect straight line, as it ceases to be proportional to I, as V ceases to be proportional to I. So this is our first limitation. Second limitation is, for semiconductors, example, diode is an example of, or diode is made up of semiconductor. So for such diodes or semiconductors, what will happen is, the graph between V and I looks like this. The graph between V and I looks like this. When V is positive and potential difference is in one direction, then the graph becomes like this. Now when you reverse the direction of the potential difference, when you change the terminals, then the graph looks like this. So this direction is I, this direction is this direction is I, this direction is V, this direction is V, and this direction is I. So this is a graph for the semiconductors, and which is not a linear graph. Okay, so this is also one of the limitation of the semiconductors. Now third limitation is, for some devices, there will be two values of current for single values of voltage. So such device or such compounds, such compounds are like one of the example of such compound is your gallium astatine. So for gallium astatine, your graph looks like this. Your VI graph looks like this. So if you see closely, for a single value of V, suppose if I take this value of V here, this value of V, then what will happen? I have one value of current here and another value of current here, and again if you go on like this, there will be another value of the current. So for a single value of voltage, there are three values of the current, which is also not according to our Ohm's law. So this was our Ohm's law, where single value of voltage will give us single value of current. Always single value of voltage will give us single value of the current, but here single value of the voltage will give us different values of the current. So these are the three limitations of the Ohm's law. But in this chapter we are just going to study our normal V is proportional to I thing. That means we are going to study only such cases where Ohm's law is being obeyed. Okay, so in this chapter we are going to study the things which obeys Ohm's law. That means we are not going to study this situation, higher temperature situation, semiconductor situation, and this one, gallium astatine situation. We are just going to study a perfect V proportional to I graph, which is Ohm's law. Thank you.